video, that is critical path method part 1. So which consists of how to make a how to calculate the earliest start time, earliest finish time, and also latest start time, latest finish time, and calculation of the critical path. So in this the continuation of that video, today we are going to see about the calculation of float. So before calculation of float, we want to know about the different types of floats. So usually in a network, we have considered four type of floats. So one is total float, second free float, independent float, and interfering. So the total float is nothing but the amount of time which the activity may be delayed without delaying the project completion. So which means that there is a time liberality will be there for which then activity can be delayed. So we can delay the activity, but that delay of that activity will not be delaying the project completion, which means that that activity is not a critical, that activity is not part of the delaying of the project completion. So that type of activities will be considered as a total float. So for example, free float, the duration of an activity is delayed without delaying any other succeeding activity. So that total float is part of the overall project completion time. Free float is the part of the without delaying the succeeding activity. So it will be given in the exam while calculating the problem. I will explain. So the succeeding activity will not be delayed, whether the duration of change can be delayed in the that activity. That is the free float. So there is a formula to calculate the total float. There are two formulas. One is latest start time of that activity minus earliest start time of that activity. Or we can consider as a latest finish time minus earliest finish time of that activity. Then free float formula is, which is free float is the part of the succeeding activities. So we have considered earliest start time of succeeding activity minus earliest finish time of that activity. Then coming to the independent float, which is the excess time available if the preceding activity ends at the as late as possible. The succeeding activity start as early as possible. So there is a privilege of any activity. There is a completion of that activity. So if the activity start means the preceding activity should end. So I want to start B means A activity should end. That is a guideline given in the network. So I want to start B, A need to end. If activity ends means which can be privilege ends as late as possible, but succeeding activity will start as early as possible. So which means that if B activity should start as early as possible, because of that, the activity A, which is preceding activity, which can end as late as possible. So there is a flexible time of preceding activity which affect this succeeding activity, which is not affect the succeeding activity as early as possible. So for that, for an activity, here to calculate independent float, we have to consider for a predecessor as well as successor. So the independent float of a particular activity depends upon the predecessor activity as well as successor activity. So the formula is earliest start time of succeeding activity minus latest finish time of the preceding activity minus duration of that activity. So it is considered by general relation between the total float, free float, and independent float. Always total float will be greater than or equal to free float. Free float is greater than or equal to independent float. So there is another type of float, that is interfering float. This is the part of the total float which is not free. So interfering float equal to total float minus free float. This is the calculation of the float. Four different types of float calculation. Now we are going to see the problem. So first we have to draw the network construction. So for that, we will draw the network here. Then we will check network and the total duration we will calculate in this slide. Then later, the next slide, we will calculate the float, different types of floats. So we will draw the network and identify the critical path here. So we have a first is A is an activity, B is also an activity which does not have the predecessor. So I will start here. So A is an A and B are starting activity, which is having a duration of 2 and 3. Then C follows A and D follows B. C follows A, D follows B, which is a simple